Hi everyone. In this demo, we will walk through a real-world example of an AI command injection attack, similar to the recently disclosed EchoLeak vulnerability in Microsoft 365 Copilot, but applied more broadly to an AI RAG application. We will show how attackers can weaponize everyday documents to quietly exfiltrate data from trusted AI systems, a threat that is invisible to end users and missed by most AI firewalls. And we will see how Pebblo from Daxa proactively detects and stops such threats with deep data context and AI runtime control. Let us start with a typical attack path. An attacker injects a hidden instruction into a GitHub issue, a subtle command designed to leak data. This content gets ingested by a RAG pipeline stored in a vector database as multiple spread-out vectors, which are later retrieved by an AI app during any related user query. What looks like a helpful response actually contains a compromised link. One click, and sensitive data is quietly sent back to the attacker. Now let's check the GitHub issue that is created by the attacker. You can see that the attacker started by adding 2 new features and then very subtly changes context and inserts an injection and asks for sensitive information in the URL. Here's what makes it dangerous. The injection is invisible to the user, yet causes the model to leak sensitive internal data. Let's send a prompt like a user looking for regular information. Tell me about new features in Pebblo. And here you go. See the response? It not only has valid info, but also includes a URL that contains sensitive information. In a variant of this attack, the URL could be auto-downloaded as an image by browser, making it a zero-click attack. It's critical because it can expose secrets like employee records, credentials, or internal URLs. And it's broad. GitHub is just one of the many entry points. Attackers can target wikis, emails, PDFs, and more. Pebblo introduces shift-left security controls that activate before runtime, during data ingestion and retrieval. Our safe connector for GitHub analyzes documents holistically, looking at lineage, where it came from, access control, who owns it, and topic intent. This deep context enables high-accuracy classification, which results in tagging the vectors as suspicious injection. If desired, those vectors could be dropped instead of being tagged. Then our safe retriever enforces retrieval policies, ensuring only authorized and compliant vectors are used, and in this case, also sees that we have a default policy that blocks anything tagged as command injection. The attack is stopped in its tracks before the weaponized data even reaches the model. Now let us see Pebblo in action. Here is the Pebblo dashboard. You can see how malicious content is automatically flagged, not just from GitHub, but this could also be from email content, public web sources, or document stores. Let's look at the GitHub issue that we already talked about. Here you can see that Safe Connector has already tagged it as command injection. This visibility turns unknown threats into actionable insights, all before the model ever sees the data. Now let us look at the semantic policies. And we can see here that command injection with other topics is in the denial list, which means that the snippet containing these topics will be filtered by safe retrieval. Let's try that same prompt again. This time, with Pebblo in place, the risky content is filtered out. Tell me about new features in Pebblo. And let's go. So here you can see that the system denies an answer, and the user is not exposed to any compromised link. In the dashboard, we can trace exactly what was retrieved and confirm the bad vectors were blocked. Let's go to the dashboard quickly. Let's go to retrievals. This was the question that we asked, and here you can see that none of the risky content is present in the retrieved context. To recap, it started with a document that quietly slipped in, carrying hidden instructions no one noticed. All it took was one innocent query, and just like that, the model enabled the exfiltration of sensitive data. But then Pebblo stepped in, detecting the threat with deep context before it reached the model. Instead of reacting after the damage, it blocked the risk in real time. The result? No exfiltration risk, just proactive, intelligent defense at the data layer. Want to learn more or see how this applies to your RAG apps? Visit daxa.ai/Pebblo